Okay, welcome everyone to Percona Live Online. Before we start, hope everyone is safe and at home. Today we are presenting about MySQL on Google platform, and yeah, let's start with it. So the agenda for today basically is a small introduction to us, speakers and our company, Shopify, and then we go on to some important concepts in Google Cloud. Then we listen to some peacetime stories, and then wartime stories, and then we conclude our talk. So something about us. I'm Akshay Suryawanshi. I'm a senior production engineer in the data stores team managing the MySQL databases. And I've started working here since September 2018. With me, I have Jeremy Cole today. He's a senior staff production engineer in the data stores team. And he has been working here since August 2018. And of course, he's a MySQL legend. Shopify, our company, is an online and on-premise commerce platform founded in 2006, now used by more than 1 million merchants. Hundreds of billions of dollars of sales has happened on the platform since its inception. We are a large user of MySQL, and throughout the Black Friday and Cyber Monday weekend, which is our peak time, we handled hundreds of billions of queries with MySQL. So that is a little introduction to us. Let's move on to our next section.
Yeah, so first we'll talk a little bit about some important concepts just so that the terminology is explained. But Google Cloud, if you're familiar with Amazon, AWS, some of the terms are very similar. Regions are just a geographic region where Google Cloud operates, usually sort of considered like a data center or a couple of buildings of data centers that are very near each other. And zones are a subdivision of those regions. Typically, there are 3 within each region, but it varies a bit by region. GCE is the compute engine platform, which is the system that provides virtual machines to run as servers, and most of our MySQL infrastructure is on GCE run on VMs. So we have the virtual machine instances within GCE. They're scheduled in a particular zone, and we use the next item, persistent disks, which are a network attached block storage system based in a single zone in GCE. GKE is the Google's Kubernetes engine. So it's the Kubernetes solution that is managed within, it's actually running on top of GCE and managed within Google Cloud. And we'll talk a little bit about that as well. That is the solution that we're using for some of our up and coming MySQL work. So at the moment right now, most of our big MySQL installation is on GCE in VMs, and we have a lot of work happening within GKE.
Okay, so yeah, after warming up to some Google Cloud concepts, let's talk about some peacetime stories and events that has happened over the last 1 year after Jeremy's talk about MySQL on Google Cloud platform. So let's start with persistent disks. So PDs, as Jeremy mentioned, they are network attached distributed log structure log storage. This is a place where you basically save most of your data, especially when you're running MySQL data or any sort of databases. So except their performance, which is usually latency of a network attached storage, they provide incredible features, especially fast snapshotting of volumes. We have utilized the snapshotting behavior to revamp our backup and restore infrastructure and like brought down our recovery time to less than 1 hour for even a multi-terabyte disk. And this is so incredibly fast that we actually restore each and every snapshot that we preserve or retain as a backup every single day, and it's happening in both regions where we run our MySQL fleet, most of our MySQL fleet. So these are like really useful features. They provide us really good resiliency against testing our backups and our restore procedures. Configurable VMs. So VMs, virtual machines, expose an extensive API, which is very useful in programmatically doing things with them. The API is very helpful. It is well documented, and yeah, we are using it in a bunch of places. Scaling VMs up and down are seamless operations. Of course, all of them require a restart, or most of them require a restart, but those are manageable cases with the MySQL databases and a good failover stack. Provisioning new VMs in an appropriate region and zone is very easy, again, because of the extensive API which is provided. Something required to build resiliency against zone failures. So we spread our VMs across multiple zones, and that helps us tremendously when a particular zone goes down, which you'll learn about more in our wartime stories as well. So all of this basically has allowed us to build self-healing tooling to automatically replace failed VMs easily, and we see a lot of failures happening uh, throughout a certain period, and we were able to accomplish building these toolings pretty easily. Again, thanks to the API which GCE provides. So GCP is truly multi-regional. Uh, Google Cloud has the most extensively spread out availability region. From what I heard last, I think they are spread across 23 regions and 70 zones, which is really good. So this is definitely helping us in building robust regional failover capability. We can failover from one region to another pretty nicely, and Shopify is able to just move all the traffic from one region to another with the use of that, and it happens within few minutes, and we can do this multiple times in a day now. We also have the ability to expand to a distant geographical region without a lot of work, yet keep the same stability that we see in our previous regions. Isolating PII data is quite achievable and has been a big win for Shopify in the past 1 year, where we launched a certain product where PII data needed to be preserved in a particular region, and GCP provides really good support for that. Google Kubernetes Engine. So GKE is feature rich on top of already cutting edge Kubernetes, which is really nice. Kubernetes is an open source project for container orchestration. We are, as Jeremy mentioned, most of our future work is happening towards containerizing MySQL and running them or scheduling them inside Kubernetes. Uh, so one of the aspects which is helpful for us is automatic storage and file system expansion, which is really easy and almost automatic, and it solves a very important problem for database administration at such a scale. Zone-aware cluster node scheduling helps schedule the Kubernetes pod, which are in fact MySQL pods, in a way that they are fault tolerant towards zone failure. So just as we built our resiliency with using VMs in particular zone, Kubernetes also automatically, or GKE also automatically provisions pods in such a way that they are spread across zones. Networking. GCP networking is pretty simple to set up, and it's really great. again, kudos to Google's networking. It's top-notch, as always. Inter-region latencies are pretty low and helps us perform region failovers for databases in the event of a disaster. So as I mentioned in my previous slides, we are able to do a complete region evac within a few minutes. And all of that is possible because we can keep our databases in both regions up to date due to these low latencies. VPC, virtual private clouds, are a great way to segment the workloads. So we segment our production workload, our staging workload separate from each other, and VPCs are a great way of doing that. And isolating the networking at VPC level has helped us achieve that, which means your staging workload basically doesn't interfere with your production workload.
All right, so it's not always peacetime, and it's worth talking about what it looks like at wartime and some of the things that can go wrong in the cloud and in Google Cloud specifically. Starting with, well, stockouts are a real thing that actually happens. We may not be able to allocate the resources that we want to allocate at all times. So the concept of a stockout basically is that a resource that you requested, whether that's a VM or a disk or something else, is not available at that time. What that looks like is that you attempt to allocate it using some API, and it just takes a very long time to show up, or you get an error saying that it's out of stock, basically. In one particular instance, in one region, we had consistent PD and VM stockouts occurring regularly for several weeks, where creation of VMs or creation of the underlying PD volumes for them would take several minutes or tens of minutes. All you can really do in that case is just keep trying until you succeed. The cloud does have some resources available generally, they just aren't always immediately available. So just keep trying and trying and trying. But one of the things that does mean is that you need to make sure that you do not, for instance, have a requirement in your disaster recovery plan that you immediately spin up a replacement instance for something to avoid downtime. You need to make sure those instances are already running and the resources are already allocated if there's a time critical component to that resource availability. One of the bigger challenges and problems that we've had in general is persistent disk. And one of the instances of this is we had a recent outage that was caused by a change in persistent disk's backend, which caused a regression for us, which caused anywhere from minor latency impacts to full stalls for several seconds of the underlying PD volume, which of course pretends to be a disk, so that means the disk is fully stalled for several seconds. There's a term, increased P100 latency came from that, which is, well, technically a true term, a bit unhelpful in describing how that looks to the user. In this particular case, it actually took several weeks for us to diagnose and pin the blame of these stalls on PD completely and properly and get Google to start working on it. So during that time, we had many small incidents, many big incidents that were caused by that, and we just have to kind of work through those and figure out what's going on. Once the problem's identified, of course, there were some mitigations we put in place. And there was a long-term solution for it, but a fun part of that story is that the mitigation for this particular problem involved attaching a very large PD volume to every one of our VMs in order to work around a problem that was happening in PD. And in order to do that, since we had so many VMs, in aggregate, we had to allocate petabytes of persistent disk and leave them attached for a few months. And probably the major outcome of that is you've got to work with your vendor. You've got to, so work through some of the technical issues with this, and sometimes you have to get pretty creative to make things work right now and get yourself back in action. Live migration is still a problem since the last time I gave a talk like this, which was a year ago. We're still seeing problems caused by live migration. Live migration is intended to avoid downtime in instances, which it does pretty well, but it is itself not perfect, and it means that we constantly have machines being live migrated and the VMs being moved around between different physical machines. The frequency of that occurring and the number of times it causes us problems directly related to the frequency of Linux kernel or Intel CVEs. The more of those there are, the more pain we have because Google has to go fix those and get the fixes rolled out generally pretty quick, and that causes us a lot of trouble. So the errors that we see right now, we see stalls related to live migrations. We're still getting host errors where live migrations fail sometimes, and then it just kills the host, or kills the VM rather. Some live migrations are still breaking NTP and causing the machines to have the time be out of sync. And we are still getting multiple migrations per VM. As I mentioned in the last version of this talk, we had seen 11 live migrations for the same VM within a day or so. And that still continues, that occasionally we see some outliers like that where the same VM just gets migrated over and over when they're aggressively rolling out a change. We also had in the last year, a regional outage where Google had made a change to their traffic routing in one region, causing basically an overload of their networking stack. And we went down pretty hard because of that. The unfortunate part of that was that there was nothing really that we could do about it while we were down. We kind of had to wait for the network to start working again before we could even fail over to get out of the region. In order to avoid data loss and to avoid even bigger problems potentially, because of the way that the region went down, we had to wait more or less for many things to recover before we could fail them over. So the downtime was several hours until recovery. So in this case, sometimes you're kind of at the mercy of your allies. We are multi-zone, we're multi-region, but that doesn't always work in exactly the way that you think it should. And sometimes that causes you extra problems. In conclusion, running MySQL in the cloud is not magic. It can be a really brilliant solution, but it can also be a real challenge. And there are some unique challenges to Google Cloud, unique challenges to running MySQL in cloud infrastructure, and unique challenges with the cloud itself. So we've learned a lot. We've had some pretty big wins. There's a blog post that Akshay wrote all about how we do backup and restore. That's pretty awesome, using Google's persistent disk snapshots. Those something like that wouldn't be easily possible outside of infrastructure like Google Cloud. So we're very happy and very appreciative of that. But sometimes running databases in the cloud can feel like you are constantly at war. And there's always something broken. There's always something burning. There's always something that you have to be working on to keep yourself running. So it's a bit of a peacetime, wartime situation. When things are good, they're really good. When things are bad, they can be pretty bad. Thanks for coming today. And we will be happy to take questions and hope that you will stay safe.